Right. So we were designing a system which was the e-commerce system, and we designed it using message broker. It was event-oriented architecture. So what does it mean? So let me give you a quick recap about that. So you see my screen, right?
Yes.
Perfect. Great. Awesome. I'm just getting my diagram. Just give me a minute. We'll start. Right. So yes, today we'll be covering about message queues. So now I think most of you would have joined, and yes, and now this is a very important class today. Last time we discussed about microservices, and in that one of the very important pattern is microservices pattern. So how does it work, right? So let me, yes, get something, right? So we have a client, right? So we designed an e-commerce application. We did a case study of e-commerce application. We added API gateway, right? So let me add here API gateway. So I will use the icons from, maybe this is there is a gate kind of icon which is denoting API gateway. Let me get that. Uh, it should be red color icon. I added. Let me get that. So yeah. Okay, yeah, got it. So this is the API gateway, right? So API gateway, a browser will make a call to API gateway. We have multiple microservices. Let's draw these microservices as boxes here. So for example, what one microservice could be, let's say product catalog. Other microservice could be shopping cart. Then we have, say, another microservice could be ordering, right? We call this order management, right? Then you may have payment processing. Right? There would be probably some external integration also. So this is our firewall, right? So this is outside world internet, users accessing the application using browser. Whenever they make a call to API gateway. API gateway routes the request to all other microservices. So client need not have to know about all the servers. There are a lot of servers because there are many other services as well, right? There are hundreds of services. Let me add one more service to give you an example. This could be, say, inventory management, right? So if we expose all these services to the client or the developer who is developing the web application, right? If I give him so many APIs, so many servers, so many endpoints, he will just run away, right? Because there are so many things. But what I will do is I will give him one endpoint, which is the endpoint of the API gateway. He will call various services from the API gateway. API gateway will be routing it. Yes. So product catalog probably will be also maybe checking some other services. Yeah, probably shopping cart. Shopping cart maybe connecting with order management, right? So because when you click on the order, shopping cart may also connect with payment processing. So here shopping cart knows, right? So maybe you have a high level function here, right? So you get the shopping cart. Maybe when you click on the order button, order management service will be called. It will check the inventory, right? And shopping cart will also, yeah, order management will take care of doing the payment processing. So this is your flow, right? And definitely your products are getting added to shopping cart, right? And maybe some details could be added from the product catalog. So shopping cart also verifies the product detail from the product catalog. Once the item is valid, it may also get the price. It may also get the inventory. Inventory you can check while doing the order. So shopping cart you can order. See here, the shopping cart service knows other services how to call it, right? So what is it? Shopping cart is a choreographer or is an orchestrator? Anyone? Right? So you know that what happens actually in choreography, what you mean by choreography when you talk about choreography, right?
Maybe creating something.
Okay. No, choreography is choreographer in literal sense. What do you mean? If I say this guy is a choreographer, what
Who
is
makes, yeah. who makes some dance steps, create some dance steps and make others to.
Right? Yes, absolutely, absolutely. So he is the central control who will direct others how to do various steps, right? So in this microservices also, shopping cart is the choreographer. It knows, okay, next service should be called as product catalog, get the product details. If order is placed, go to order management. Order management also is a choreographer because it knows, okay, first for order management, I should check the inventory. If item is there in the inventory, I should process the payment, and payment processing, once it is completed, once they, for example, this is maybe payment gateway, right? And this could be external also. And it could be a service which is running on the cloud also. So here, let me get a cloud. Right? Cloud, anyway, everything is running on the cloud, but what I mean by this is it's an external cloud. So let's say we have something, yeah, let me get some other, yes, say this is basically a different service, right? From somewhere else, right? So this is the payment gateway service. Maybe this is PayPal, right? Or Paytm or any other payment gateway, right? Let's take this example, Paytm. So yes, once the payment is successfully done, Paytm will call definitely bank. I'm not denoting, but yes, the payment confirmation will come, and then payment processor will confirm the order, and order management service will also place the order, and probably there will be other module also, which is maybe logistics module. See here, a lot of direction is required, right? By order management. It has to make various services calling. It has to call various services. This is one way of communication, right? Here, this is less flexible because you need to have some sequence of operations in order management. Configuration is difficult. You have to change the order management service a lot, right? So this is what is called choreography. Right? Now let's talk about orchestra, right? In orchestra, what does it happen? See, in choreography, what actually happens in the runtime, things are decided what to do. If payment is failed, then order management will decide something else, do something else, right? So everything is decided in the runtime in choreography. But in orchestra, is it designed? Everything is decided before, or it is decided by a single person, right? So in orchestra, you have a group of people who are performing, and they will pre-decide. There is no such leader, right? And I'm not talking about, say, some music director. Assume there is no music director, it's some show. Say, for example, show performance by Batsa or show performance by any other singer. So what would happen is everything will be decided before. In the show, they will be performing, right? So that is called orchestration. So now how to implement this in the context of microservices architecture, right? So that is what I will cover here. So let me show you here. I covered API gateway in detail in the last two sessions. So people who have missed this, please see the recording. You will get understanding of it. So I again have the same services, right? So let me just get these services. Right. So, right. Okay. Now this is shopping cart. Is order processing. Okay. And then here you have payment. Right. Now what I will do is definitely, though the routing will happen from here based on what is the API which is called. Maybe here some user has called slash product search equal to, right? Say some text iPhone, right? So this is someone who is searching for product, right? So here I say product name equal to iPhone, right? So something like this. This is a search query. So now API gateway will see that yes, there is a pattern called slash product. And this pattern is configured in API gateway to point to the product catalog, right? So this is how the call will happen. Same is the story here as well until this component. But then yes, you may have another request. I'm going into more detail now. Here you have shopping cart service, right? So let me say shopping cart, and here you can't search, you don't search the shopping cart. Basically what you do is you load the shopping cart, right? So you will say probably ID, and maybe shopping cart is using user ID, and user ID is say some name, right? This is for user ID or user name better equal to Anil, right? So something like this, if I am kind of making a query, basically. So here, this would be say a get request, right? And this is also get request because we are getting the detail. We are fetching. Now we are not creating any new record here, right? Again, I've covered REST APIs also in the previous session. Please have a check on the previous session for REST API. And so here what I'm asking is shopping cart. I say load the shopping cart, and probably I'll say there is a parameter named username equal to Anil, or maybe I may have something like this, an API path, right? So this is my ID. This part is ID. So there are various ways of forming a URL, URI or URL. But for API gateway, what it says, sees the pattern like shopping cart. So there would be configuration that maybe the configuration is done in the table, right? This is the table. And here in this, you have here first column, which is the pattern. Second column is the endpoint, right? So here the first pattern is, I say slash product slash dot, right? Second pattern is slash shopping cart, right? Slash again dot, because any user ID could be there. That would be fed by the UI. Whoever is the user who is logged in, that particular user will be logged in. And endpoint could be 10.2, 30.23.1. Assume this is the IP address of this server, right? Like this. Or there could be, based on various services, there will be more configuration done here. So here, maybe this is say 11, and this is the IP address of this server, right? So based on various requests, this call will come here. But as I said, here we were doing some orchestration here. No, sorry, choreography, right? But here we don't want to do that. So what we do is we add a message queue. Let me add a message queue here. This is the message queue. right? In the message queue, what we also have, we have a, let's say, topic, right? So here the topic is some shape I have to add here. Let me add a shape here. This is a topic, and let me make this shape sharp edges, and little bit slightly I will try to make it look like a topic. Yeah, let's say this is the orders, this is the topic, right? So what will happen here is product, probably people will search, they will add it to the shopping cart. In the shopping cart, user may place an order. When someone places an order, a new message is created. And we also sometimes use the term event, right? So event and messages, they are the same thing. In this event, you will have maybe product ID 1. The quantity is, say, 2. And this is the product ID. I put PID equal to 1. And maybe this is the detail which is being placed, right? So let me say this is an event, and the event name is order created, right? Now there is an event in the queue. Order processing will be listening to the events, will be monitoring the queue, will be observing the queue, will be subscribing to the queue. See, all these terms are synonymous. They are used, but it means the same thing. So rather than shopping cart instructing and calling the order processing, order processor will have the logic that whenever there is an event, please take this message, process it. It will process, it will ask for the payment, right? Then maybe one more component which we need is inventory management. In inventory management, yes. So here inventory management will also be listening to the queue. It will see that there is a new order created, right? So it will do inventory check. It sees that, okay, the product ID is 1, quantity is 2. It will check in the stock if the item is there. If the item is there, then it will update price, right? Maybe this is 200 or amount cost, right? So cost would be 200. Let's say we call it amount, will update. So this is done by the inventory management service. It will update the message, right? This message, and it will also update the status. Status will be, rather than order created, we can say now order processing, right? Or order is pending. Maybe some name we can give to this event, order pending. Now order processing may look into this queue again, and it can see that this is amount 200. I would ask payment processing. Rather than this, payment will be watching this, right? It will update this, that order. So rather than this status, it may put the status payment processing, right? And then if after some time the payment is processed, you may get payment completed, right? And then once payment is completed, maybe order will pick up, order processing will pick up, and it will do more inputs. It may do something more, or the logistics module will ship the item, right? So everyone is listening to the queue, right? You see here, everyone is connected to the queue, and asynchronously, no one is waiting. They are busy doing different tasks. So when order processing, there is a predefined flow which has been configured in the message queue. And everyone reads the message queue, updates it, and this is what is called orchestration. Right? So these has two benefits. Right? So everyone is reading and writing to the queue. Right? They are updating the message. This is the message which has the status, which has some values. It's like a database, right? And at the same time, they are also doing the processing from their side. So this is difference between orchestration and choreography. Right? So let me remove all these arrows because these are not required. You should understand because they are all connected with. Better way to depict this in a diagram is I will share. Always never try to put all these arrows because this will make your diagram difficult to understand. Let's move this event here. You know that this is the event, right? So this is what is the topic. You may write here the topic so that like this, so people understand this is a topic because I just put a rectangle. This is a queue. So let me put also here message queue word, right? Let me call this, I can say it's Kafka, right? Or could be any other message queue. There are various message queues, RabbitMQ, whatever could be used. But yes, here Kafka is good queue, which we will be using. And you have here all the microservices. This is your backend, correct? You can call here backend. And to show that every one of these service is communicating with it, you can draw here a connection like this, right? So this shows that there are all the services, they are connected to message queue rather than individually connecting the arrows. This would be right way to kind of suggest that this is how the processing is happening. So this is about your orchestration. Right? So here, no one is controlling anything. Everyone is acting as per the pre-configured rules. This is orchestration. Now, the advantages and disadvantages of this. First one, I said that you have here a sequence, right? That means first thing is you will search the item in the product catalog. Next thing is if you find the item good, you will add it to shopping cart. Third step is maybe shopping cart will put more details from the catalog about the item. And then maybe order management, once the shopping cart status is changed to order, user clicks the order button, order management will do some processing. Maybe it will verify the order. And based on the amount, it will request inventory check and it will probably get the inventory. It will also request. Next is payment. Payment processing will call the payment gateway. And then once payment is processed, it will be confirmed. This confirmation will come to order management. And then finally, last step is logistics will trigger. So there is one after the other stuff happening, right? Now, assume while the processing is happening, some module crashed, right? Let's say inventory management crashed, right? Or order management crashed, right? And our item is say iPhone. You ordered iPhone. I told that yes, you have to pay this much amount, 1,50,000. And if it's any stage, some server crashes, you lose this order. There's no way you can get this order back. Yes. And there's no retry also possible. Maybe you can have some retry, but yes, again, this has to be choreographed. in your logic. And your one module needs to know about the other modules. So there is a lot of coupling also. So this is the disadvantage. And other disadvantage is, assume the payment processing is happening. So order management has requested payment processing. And this is taking, let's say, 10 seconds, right? Payment processing may take time because your bank account details will be verified, and then you may be asked for OTP, you may enter OTP, and then the money will be deducted, and then it will be transferred to the merchant account. So there could be a lot of processing which may be happening. It may take 10 seconds. In that 10-second, order management is stuck because it has to wait for this payment to be processed. It cannot serve other requests, right? So this is kind of a blocking scenario where this order management is blocked until unless this response comes. It will wait. It will be waiting, right? So here maybe you will need more hardware here, more servers, and you will have more instances of order management to process multiple orders. But in this case, you don't have that scenario. You write the topic and update the message, and then you start processing other requests. And when the other modules, they will finish their task, anyway, they will update the message queue. And you are listening to the message queue, so you can get to know, you will get notified when this message is updated, and then you can take the next steps. So no one is waiting. This is all happening asynchronously. This is the word which is used for asynchronous communication, right? And this is also known as event-driven architecture because we are interested in events, right? This one is synchronous communication because you have to wait. And this is maybe just microservices architecture. Maybe you are writing to the database at various stages. But yes, again, if some module crashes and you are not able to write to the database, you are going to lose that information, right? The processing will be lost and there's no way to recover it. And yeah, so let me draw here DB. So for every microservice, there will be a DB because yes, you would need database to do a lot of storing some stuff and doing some processing and all, etc. But yes, here in this, you have this message always there, right? If something crashes, you can also take this again. You may have multiple processors also if you want to scale these jobs, right? And everything is more reliable here because there is a source of information, which is the message queue, from which you can always get the message. If something fails, you just have to read that message again, right? And you know that this message is not processed because the status of this event, you will not update. When I say status, I mean this. So we may have various states here, which is maybe order created. This is the first state. Second state could be order processed, right? Maybe you just check whether the quantity is correct. Is the user eligible to buy that? Is that delivery possible on that location? Maybe some business rules are there. Once order is processed, you say inventory check, right? Once inventory is there, you have another status, which is payment pending, right? You may decide your own events. This is the business logic. And then once payment is, say, payment processed, right? and payment completed. You may call this payment processed or payment completed. And then once payment is completed, you may have a state which is order completed, right? Order shipped, and then order. Once the order is shipped, right? Then you maybe say order delivered, you will get the final stage, which is order complete, right? You may have a lot of complications or some complexity here as well. So for example, you may want to cancel the order, return, refund, various use cases will be there. But see, all these stages you can model in the message queue, right? So these are the steps which are processing. You may have various steps, so need not have to be always linear. Sometimes payment may happen after the delivery. It is pay on delivery. So that kind of flexibility also you can put, right? So that is also possible based on various scenarios. So if the payment is via credit card or debit card, then you do the payment processing first, or otherwise you may do payment pending delivery first. Just deliver if customer is a trusted customer, and then do the payment processing. And then once you have the payment done, order delivered, then you complete the order. So you may decide your own logic here and configure. And based on this stages, different microservices will perform different actions. And you have a lot of here flexibility, because you may change this, but you don't need to change the individual microservices, because all the logic is placed in your message queue in one place. In this case, in choreography, if you want to introduce new scenario like pay on delivery, you would have to modify various microservices, right? So here maybe you have to modify order management. You would also need to modify inventory management, and you would also need to modify payment processing, and logistics also you will modify, because here you will ship the item even without receiving the payment, right? So a lot of changes will be there. So this is less flexible. So this is about message queue. So let's now start diving deeper into message queues. Any questions until now? Everything clear? Because now I'm going into internals of message queue. What exactly is a message queue? Right. So I see one question from Funny. Yeah, there can be multiple topics. So I also see one question from Ramesh. Ramesh is saying, can we have multiple topics? Yes, you will have multiple topics, right? So same queue you can use for multiple use cases. And then in that case, you may have another topic. Say, for example, you may have observability in this particular process. So you have another queue here. Let's call this queue logging queue, right? Log messages, right? And logs. Maybe you have a UI here, or there is a log aggregator also. So, right? So what actually is happening is, as and when you are processing various services, you are also writing the log of all of the steps, right? So that could also happen here. And in this case, you have two message queue, two topics, right? Same message queue, but you have two topics. And no other person, no other microservice is listening to the logs, only the log aggregator, right? Log aggregator is maybe a dashboard which shows all the errors to developers. This is the microservice all about. It is the only thing which is listening to this topic, right? So this is how you may have multiple topics in this particular message queue. So we'll cover this again in detail. I am going to take this topic in more depth so that you can design the systems well. But yes, you just see this. This is how you should draw the architecture when you are discussing any design in the interview. You can discuss orchestration versus choreography also. You can give that, yes, these are the options which you have. These are the various approach. This approach looks more better because here this is more reliable and this is asynchronous communication. It can process the messages fast. You can get more efficiency here because there is no waiting required. Now, the other question from Funny is this single point of failure, right? This message queue part, right? So the message queue you can always create as a cluster of system. So Kafka is very reliable because this is not one single system. This is also cluster, right? So we'll cover that. After a few topics, you will understand how the clustering of Kafka happens and how it is not a single point of failure. It is also very reliable. It is highly available software, right? Basically, it is distributed. Messages are distributed. They are also replicated. If few nodes crashes, you have replicated data available and overall the system will be functioning and it is not a single point of failure. Right, so let me go to some more detailed discussion on message queue, right? So message queue definitely is when you are asked what is a message queue is a communication mechanism using which different microservices can communicate by exchanging messages, right? Message queues are also called message broker because broker is something who connects sender and receiver, right? Broker. When you do a renting, you use a broker. So you have a landlord, you have a tenant. Broker acts as an intermediate between two microservices. In this case, two people assume one is person who is renting, other one who is lending. Same way here, you have a message broker. It is helping the two parties communicate. So the same thing is also known as message broker. Now, what is the meaning of queue? Queue is if all the order processing is busy, the messages will stay in the queue. So it is also a buffer. And as and when the order processing is up, it will take the messages. So here there is one more advantage. Assume order processing is down in the first case. Here, let's say this is down. Whatever orders will be done in this particular time frame, they will be lost because there is no buffer, right? So if you click on order, no response will come, you will lose the order. So this is bad for the business because they will be losing revenue. Here, so the application is not reliable. In this case, it increases the availability because message will stay in the queue. Now order processing is down, no problem. Queue is there. Queue will keep storing the messages, the orders. And once this is back, it will pick up the order, it will process it. So this is about order processing, how it is more reliable in case of message queue. So it adds reliability. Right. It also makes the application more scalable because you can handle large volume of messages, right? Because you don't have to wait. And you can keep adding more and more processor if you want faster processing, right? So there's no limit and you can keep adding more processors because you can always mark what messages are processed and you can partition the topic among different instances, right? So this is how you will partition. So we'll cover that. Also, how do we scale? Right. So basically, it is also acting as a load balancer here, because when you have multiple orders and multiple instances, just let me fix this round edges. Yeah. So that looks good. Yes. Now you have multiple instances of order processing. Maybe you will need also multiple instances of product catalog, and yeah, all the services will be having multiple instances. Now, when there is an event, there is a kind of load balancing which will happening here automatically, because you have multiple messages, and messages can be assigned. One processor may be assigned on a round robin fashion for a message, then other will start picking up. Like that, it will keep happening. So there is a pool of processors, and there will be many messages, and messages will be picked by pool of processors. We'll cover this also in detail. Right. So this is pure microservices architecture. Or maybe you can say vanilla microservices architecture, because here you have a lot of features here as well. You have here caching. You have here authentication. A lot of optimization is happening in the API gateway. And yes, you may have all the communication happening again through API gateway. Basically, I've drawn these arrows, but you can also think of that these are also client. So when I say 4, shopping cart is communicating with order management, it also means that maybe it is communicating via API gateway, right? But you will depict in architecture diagram like this, because you can always understand that all the communication is happening through API gateway. Because directly you may not know the endpoint of shopping, order management, or any other. So you need to look into that database. Where is that database gone, which I created of endpoints? Yeah, it's here right now. Here, yes. This database is required to refer to any service. So all the communications happens via API gateway. But yes, direct communication has a flaw, because if the crash happens, you will lose that communication. But in this case, if it is via message broker, message is preserved in the queue, right? Now, there is one more thing which is called batch processing. Does anyone know what is batch processing? So what I can also do is, let's say, yeah, I will take an example of logging, right? So let's say this is a log aggregator service. What it is doing is, it is maybe summarizing all the logs. And in case there is an error, it is sending emails to some developers, right? That there is some error. Let's say this is the service. Right. So this is the developer, and he will get notified. Right. So let's call this there. Right. So what will batch processing do? Say, assume he has subscribed. He says, okay, never give me messages as and when. I want to see messages on maybe per hour basis, or maybe per day basis, right? So you may have a timer job here, scheduled job here. So you have all the messages coming in the queue, right? So as and when there will be some errors which will happen, maybe, right? There could be many things which may be happening, but yes, as and when there is an error happening, since always the messages will be stored in the queue, you may do batch processing. So here you have maybe some timing job, and this timing job timer is per day in this case, right? So we say 24-hour timer is running, and every 24 hour it will pick up all the messages, it will send email to this developer. So some use case like this is also possible, which is called batch processing. Batch processing is nothing but not doing jobs one by one, doing jobs in bulk, in batch, is what is called batch processing. So is that clear? Batch processing, it's also possible via batch processing. Batch processing can also be done using message queue. Here it is difficult to do batch processing. Yeah, you can do it via database, but yes, no, you have to yourself write the messages to the database. You have to by yourself create a timer job and then make a call and then take out the messages. It's tricky. It's not that easy to implement here, but here it is very straightforward. So let's get into the details of message queue. And in particular, mostly the concepts I will be covering are from Kafka, right? So Kafka is a message queue which can process millions and billions of messages. So let's talk about Kafka. So basically, what is Kafka? Kafka is a message broker. So you have multiple services. Let's say microservice, right? It could be any service. And you have another microservice, right? Let's say microservice 2. Now, Kafka can be deployed in cloud, right? So let me get a cloud. So this is my cloud, right? So yeah. Okay, let me get another cloud. Yeah. Right. So again, this is my cloud. I'll write here. Cloud. This flag is no problem. Okay. It's there. But yes, let's depict Kafka with some ellipse, right? This is my Kafka, right? So basically what I have here is cluster of computers. Basically, there will be multiple nodes here. So as I said, there are multiple nodes. It's not one system. It is multiple nodes. Let me write here, node, right? Now, when you have multiple nodes, that means you should know where all, so as I said, there will be topics also. So topics could be in one node. So let's say this is our topic. Assume this is in node 1. There could be multiple topics. So this, let me call this T1. Then there could be one more topic. Let's call, yeah, T1 is also here. And then we have another topic, T2, right? Which is here, right? So node 3, right? I also have T1 here also because maybe I want some reliability also. Basically, you need a table here. You need some coordination. There should be one place which has the information that which nodes have which topics, right? So basically, you need coordination between clusters. So you have nodes here, and then here you have the topics, right? So if suppose a new message comes, right? Service 1 is creating a new message, posting a new message. It should know, the Kafka should know in which node to put the message. So someone has to decide So it will decide based on maybe some table where you have say node 1, node 2, and then you have, yeah, let me put this. And in this nodes, we have topic 1, right? So something like this, you will have the table. So you know of topic 1, you have to place something, you have to write in node 1, node 2. But yes, who is doing this coordination? This is something called zookeeper, which will be doing these coordinations, right? It will be maintaining this table and it will be coordinating all these nodes, ensuring that messages are placed in a reliable manner. And whenever they are getting consumed by other services, they are also being read properly, right? So this is about zookeeper. Right. So what is the features of zookeeper? Basically, I'll write down here. So one feature is, as I said, cluster coordination, right? Basically managing nodes and keeping track of the nodes and also taking care of the health and availability, because these systems will be up and down. It should know that if some node is down, then we should read the message from other nodes, right? So this is something, a functionality of zookeeper. Then other functionality is leader election, right? Okay, but yes, I'll come back to this because we have to cover also one more use case or one more concept, which is called the concept of partition. And it does configuration management. Right? So there could be various configurations which also be kept. For example, configuration about retry. So there could be acknowledgements which can also be configured with every message, right? So this is dotted line, dotted blue part is the cloud, right? Cloud, every node is inside the cloud. So yes, just erase. So this is what a Kafka is, and you have microservice 2. One is the consumer, one is the producer. So this is called producer. This is also known as you have publisher, and this is called, here also you have multiple names. You can call it consumer. You can also call this subscriber, right? So you can use either publisher, subscriber term or producer consumer. It means the same thing, right? So basically, what is a topic? Topic is nothing but is a collection of partitions. P1, P2, like this. So topics will have partitions. Now, what does it mean? Right. So as I said, topic is like a table, right? You can think of that this is like messages are like row in the database. And we also covered last time that these messages may be there permanently, or you may configure to delete these messages maybe after every 1 week, 1 month, 1 day, whatever is your requirement. Yeah, if you see that, okay, if an order is pending since maybe 1 week, then we may just ignore it because maybe otherwise you will run out of space. So you may have a lot of configuration. This is again done in Zookeeper. But yes, topics are like table. And as in database, you do sharding. Sharding means you are dividing the database into a small database. Each database will take care of one partition. Same way in topics, you can create partitions. Partitions are like shards, right? So basically, let me draw again this Kafka architecture, but here this time I will draw the partitions, right? So you have this cloud where the Kafka cluster is there, and in this you have topics, right? So topics are there. Within this topic, you have partitions, right? So you can say that these are the partitions. How does this partition help? This we will cover. So this is topic 1, right? And what is, let's say this is the message, right? So microservice 1 is creating a message, right? So this circle is the message, right? Let me place this. So it goes from microservice to the topic. It is going to one topic, consumers, right? You will have consumers also here. Consumers will consume this message, right? So this message, this which I have denoted by circle, will sit in one topic, right? Assume there is another message which has come. Now, this is second message 1. This is message number 2. Topic could be configured so that you may load balance. I said that we can have load balancing, right? Like this. You may have multiple clusters of servers or consumers, right? So you may have, say, assume 2 consumer. One is looking into topic 1, right? So this is the first one. The other one is looking into topic 2. So this way, you see, you are doing load balancing, right? From one microservice only, you are creating 2 messages. But yes, the first one is going to topic 1. Second one is going to topic 2. Sorry, partition 2, right? So I should name it also partition 1, and this is partition 2. Right? So first one at the top is partition 1, partition 2. So this is the concept of partition in Kafka. Right? Again, you may have multiple topics. So you may say, okay, there is multiple topics. So here you have topic 2. And you may have within this topic also multiple partitions. Maybe in this time you have 3 partitions, right? And maybe this consumer, after consuming this message, is creating another message, right? So that is also possible. So a consumer could be in one scenario, consumer, but in other scenario, it could be producer of message, right? So that is also possible. And then there could be several producers, several consumers, right? That is also possible, or the same microservice may be producing and consuming its own message. So even that is also possible, right? So these are various scenarios which are possible in microservices architecture. Right? So again, when you have 3 topics, so then you will be writing to either topic 1, topic 2, topic 3. So like that you will be doing. Right? Let me like this. Correct. Right? So something like this will happen. Yeah. So this is the second detail. So yeah, let me again draw. Here, this message is being read. This is message 2. And this is message 1. I hope you understand that, right? And same thing could happen here. The same message could be, yeah, new message. Let's say this is a new message, could be sent to another topic. So topic 1, this is topic 2, right? So, right. So basically what will happen is, yeah, again, these topics could be residing in different nodes, which I covered here. So again, you can visualize that there will be zookeeper, which I have not drawn, but yes, here, let's say you have a zookeeper also here. Zookeeper is a software which is running on one node, which is kind of a central node, right? Hope you are understanding this. So zookeeper is a part of Kafka.
So Zookeeper controls these nodes, right? Whenever one fails, it will make it work another.
Right. Correct. So right. So basically, yeah, this is a software now in upcoming releases. They are replacing this with some other component, K-Raft and all. But yeah, you should just know that there is something which is called a coordinator, which is a zookeeper. Because yeah, you in system design, you should have a fundamentals correct, right? You don't have to get into that internal details. Maybe tomorrow they may create another coordinator which they may call, say, raft or something, K-Raft or whatever. They may name some other thing. All these softwares are always evolving. But yes, the concept remains the same. You should understand and you should be thorough with the concepts. Right. Now, let me also talk about another concept which is called leader election. Right. This is what I told here, leader election. What is this leader election? So let me draw again another Kafka instance, because otherwise it will become clutter, but here you will understand it clearly, very clearly. Right. So you have microservice 1, you have microservice 2. Right. You have a zookeeper, right? And you have topics, right? And topics, and then you have partitions also. And you have nodes. And let's draw the topics. Yeah, let's say this is our topic, right? So let's say this is our topic. Oh, no, let me use, otherwise we'll get confused because I use some other shape. So let's say the topic is, yes, this one. This is this is the topic, right? So as I said, this topic, let's say we have only one topic right now, and we have multiple nodes, right? Node 1, node 2. But I said the messages are reliable, and this is not a single point of failure. But you were now this thinking, why it is not a single point of failure? Yes, zookeeper is definitely a single point of failure. So that is what Kafka is working on to improve the performance of it and making it more reliable, maybe having more distributed mechanism. But yes, here you can say zookeeper is a CSPOF, right? But yes, even if zookeeper is down, you may reinstantiate it and your messages are not lost, right? So yes, you always have some drawback, however well you design things. But yes, this topic 1 is replicated in both the nodes. So as I said, there is a message which is sent from microservice 1. What is happening is this message is going to be sitting in a topic. Let's say topic 1, right? If I only put this message in node 1, then if node 1 crashes, I lose this message, right? So this becomes unreliable. So what I will do, I will create another node. I will replicate this. I'll keep a backup of this, right? So this is again topic 1. And you have another message here. But you will say that, yes, if I have 2 messages, it may happen that when some consumer is reading it, right? Now this is consumer, not a producer here. This is the producer, right? So here you have producer here, right? So now the problem is here that if I am reading here message, from where to read? Right? Assume now this is not drawn, so nothing has gone down yet. Everything is running. Yeah, if one is gone down, then no problem. You know that this is only one node which is running because Zookeeper is tracking the availability of all these nodes. Right? There will be multiple other nodes also. Let me represent this with the dot. Right? So there are many nodes. But yes, when we are considering node 1 and node 2, from which node to read if I am interested in reading? So the reading will happen from a node which is the leader. So one node will be tagged as a leader node. Right? So let's say this is the leader node. Right? Leader node. And yeah, let me use a term underlining, or maybe I use some other symbol to show, yeah, this is the leader, right? So this is the leader. If it goes down, there will be other nodes, right? Node 3, node 4, node 5. So Zookeeper will take care of electing the leader. So this is leader election. This is the feature. Consumer will always read from the leader, whichever is running when leader is available, right? Leader will always be available. Other nodes are just like slave nodes. It's a same concept as master slave architecture. You read here from the leader. Remaining nodes, you are not bothered. They are just as a backup. So this is about leader concept in node, right? So basically other nodes you can call follower. So whatever, so you read and write both in the leader, and follower will just copy what is leader is doing just for backup purpose, right? So again, so both these concepts clear, I believe, right? Partition and concept of nodes, concepts of leader. So yeah, the message which will be read is from read from topic 1 of node 1, because this is the leader.
So, Tarun, can I say like this, microservice or the producer, they will put some information, in the
Yes.
node, and the customer, us, will read, will get that information on the display, right?
Yes.
This is how it works, correct?
Consumer is the consumer who may not get the information on display. He may also use it and do some processing, right?
Yeah.
Always, and this output could be something else. But yes, maybe he is reading this information and generating another output, and that may be displaying, right? So basically it's consuming the message, and it can be doing many things from it. It may be just storing it for future usage, or it may be displaying it, or it may be displaying something else based on this, right? So these are just microservices. You can think of these are the functions which takes an input, and it may give output, or it may just return void also. But yes, it is using this message, and message contains important information, right? As we saw, in this case, the message had information like product ID, quantity, amount, right? So message are like objects, and you may call it event also, and you may call it message also. So this is all about Kafka, right?
So Tarun, as you said previously, so every logic code will be in Kafka, right? Correct? The logic.
Yeah, as a configuration, right? Absolutely. So this is the, not the logic, the orchestration logic, right? Orchestration logic will be in Kafka.
Okay. Okay, I got it. I
What
got
is
it.
the sequence, what to do, all this
Yeah.
will be there. But yes, definitely code for payment will be here. Order processing will be here. Shopping cart will be here. But yes, about what to do next, that process will be in the Kafka. That is called orchestration, right? So you can think of that you have blocks, which is the logic, right? Which are functions. But the arrows in the flow chart, how which block is connected to which other block, this is stored in Kafka, right? So here I have this sequence, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Like this. But this ordering information, how is it connecting, right? Maybe like it is like, let's call this product. I'm just writing short form. P is connected to S. S is connected to, say, order processing. S is also connected to payment, right? Let's assume this is how the logic is. Maybe I just put here like this. You may represent it, right? This is step 1. This is step 2. This is step 3, right? So this thing is, these steps are stored in Kafka, right? This is stored in Kafka. But what is inside P is stored in product catalog and payment, etc. Right? But yes, so adaptable. You don't have to change the logic within this. If you have to implement some new functionality, new business process, say for example, assume tomorrow you decide that in the payment processing, you will also do GST calculation. So you may introduce a GST microservice here, and you may introduce this step wherever you want, right? Government says, okay, do GST collection every transaction. So you can say, I will put here this step to GST. Tomorrow, government says, okay, no, GST is not required for this particular item. You may remove this particular step. See, everything is choreographed or orchestrated from message queue. Here in this case, you have to change this, right? Maybe you have to change whatever modules are impacted because of that. Now, one more thing which I will discuss, one more concept. See, I've drawn a circle here. There is group of consumers, right? Basically, you have here group, right? Let me call this group. So as I said, consumer 1. So basically, yeah, you have consumer 1. I'll also make it separate, or assume this is separate. But yes, then you have consumer 2 also. Let me separate it. Need to move it here, move it here. So consumer, yes, I have separated it. And this is, say this is consumer 2, right? So, or better. Right. Let me draw another figure because this is an interesting thing. Yeah, right. So rather than trying to explain in the same diagram, I'll explain with the help of a new diagram. But yes, we don't need this. We'll remove this part. So we are discussing another concept, which is group. And what is group coordination in Kafka? Because this is another important thing. Assume, yeah, this is also possible. Assume this is lead code. We are doing this as a lead code application, right? So in lead code, assume this is the UI where you are typing the algorithm, coding the algorithm. So this is maybe your code editor, right? And in code editor, you have the run button. When you click on the run button, what actually happens is the code is inside the message is sent to the server where it will be executed, right? So you have here multiple servers, right? Say maybe this is Java code, which is executed, or maybe you can choose what all, you can choose various programming language. So when you say run, and you also send a parameter, you share the code. So what is coming in the message is your code. Then it will also share the language, right? These two information is contained in the message, right? And definitely you will have the username who has this code. That is also important, because if they have to calculate your score, etc., then that is also to be kept. But yes, you have here the server 1, server 2, right? When multiple people are running, these code will be sent in the topic. And definitely it will take some time for compilation to happen, run execution. There will be test cases, execution, etc., which will also happen. But yes, you are load balancing here. As I said, partition 1, partition 2 will take one message from some user, then other one will go to partition 2. This way the load is balanced. And then in the group, you may also have multiple consumers, right? And these messages are now coming to different consumers. So this will ensure that for every partition, you have a consumer assigned, right? So this will ensure that no message is processed twice. And every message is processed efficiently. So basically, you have a pool of consumers, right? And then each of consumer is assigned to a partition. This way you can get each and everything executed efficiently. And maybe, yeah, they may be publishing something in another topic, which could be the results of whether the program is successful or not. So this is one way of this pool is nothing but it is a consumer. And this coordination, it may have happened that someone write a really buggy code, and while executing this code, this consumer one crashed, right? Now what to do? Maybe this partition will need to be assigned to some other consumer, right? So it could be assigned to consumer 2, or it could be assigned to whatever available consumers are there. So this is called group coordination, right? And again, this group coordination is done by Zookeeper, right? So this is another functionality of Zookeeper. And I wrote here 3 things. One is cluster coordination, which is about the node and maintaining topics. Leader election. That means if one leader is down, then who will be the next leader? That is again kind of a node coordination or cluster coordination also. Configuration management. If I have to replicate the topics, where and all, how many days to store the message in the topic, etc. A lot of configuration could be there. 4th functionality is group coordination, right? So if you know all these concepts in Kafka, you have good understanding of message queues, and you can design any system very effectively using Kafka as message broker. right? So no questions. So if everything is clear, then we can move to next topic.
Yes, Karan. Yes.
Right. So so I'm just opening the previous lecture notes. In the previous lecture notes, I also kept a plan of what all topics to be covered. Yes, one topic which I have to cover now is about containers. So just let me see. We'll cover containers then. So just a minute, let me open the notes. Right. Yes. Because I'll show you also quickly, because sometimes with one glance also these diagrams are clear.
So RabbitMQ also will have same kind of features.
Yes, yes. RabbitMQ is also same kind of message queue. Right, but yes, again, no. I would suggest Kafka is more popular, so just worry about Kafka.
We all, yeah, we already using Kafka, and in another application we are going to use RabbitMQ also.
Yes, yes, right. So both have some advantages and disadvantages. And yes, as such, in from the system design perspective, you can use anything, but yes, based on some specific implementation or team needs, you may choose one over the other. Right? There is something called ActiveMQ also. Many products are there. So yeah, they do the similar stuff. So yes, this is what I discussed last time. So this is about monolith versus micro services architecture, how it evolved. And this is about, yeah, same thing which we discussed. But yes, you may use a database, load balancer, how to do load balancer. I covered load balancer part. Then we covered microservices, breaking down the microservices, how different teams can work on different microservices. You can view all these in the recording. And then we discussed about the pros and cons of microservices and monolith. And then we discussed about REST architecture, REST representational state transfer. I introduced about message broker and API gateways as well. So API gateway, different kinds of load balancing algorithm. Load balancer, API gateway could be load balancer, it could be reverse proxy, it can do SSL termination. It can have various features like rate limiting. You can have API management. API management, something like having API key and tracking the usage of API, and you may charge also based on the usage. So we covered a lot of things on this. We covered about reverse proxy, because API gateway could be a reverse proxy as well. And we discussed about some of the other protocols which are faster than REST, gRPC, protobuf. GraphQL is another protocol. It is for querying, and it reduces the network load by only sharing required information to the clients. So this is what we covered in the previous session. And then, yes. So yes, even prior to that, we discussed design of payment gateway. So earlier, yeah, this is about design of payment gateway. And in payment gateway also we used message queues. So this message queue understanding is useful because in payment gateway, we made use of message queues because again, processing of payments are important here. And different, see in payment gateway, what was the advantage of adding message queue? You remember, anyone remember? Reliability is important in payment gateway. Performance
Yeah.
important, but performance was the main reason because we have various components, microservices. We want these components to communicate fast, right? If there is point-to-point communication, then there would be more load. And the scalability also increases with the message queue because you may have group of consumers and each could be assigned to different partition of the topic. And here you improve the scalability also. So here message queue benefits with respect to improving the performance, improving the reliability. You may also have a retry mechanism in case the consumer is not able to process the message. It may pick the message again and again until it is successfully processed. So there is a lot of things which can be achieved with message queue. So this is what we discussed. Okay, so let's then work on containers. So yes, let me again come back to the diagram. We will talk about containers. Containers is another important topic. But yes, before that, we'll cover various topics. So let's discuss that. Yeah, you know everything about server, right? So what is a server? Server is a hardware. Assume you have to deploy some application, right? Assume you are working in a small organization or you are working on a startup. You are the founder of that startup. Now you have, say, 10 employees, right? So you'll have a website of your organization. Let's say you are hosting this website on the server, right? Definitely you have to host this on the server. You can't host this in your laptop because your laptop, if it is down, when you close the laptop, the website will be down, right? If your laptop run out of the memory or runs out of battery or you are restarting it, you are making your website down. Servers are systems which will always be running, right? So this is about server. You will host your website. Now, tomorrow you decide you need a payroll server also. You have to process salary for 10 employees. You need a server for doing payroll processing, right? So, but the problem with this is you have to purchase another hardware, right? Now, the other thing is what you may decide is, okay, I have the server, which is this, we call it web server because it's hosting your website. This is, yeah, maybe payroll application, right? So we say payroll app server. You may say, okay, I already have a server. Why not put this in this same server? But let's say some components which you are running here is maybe you are running, say, Apache server, Apache HTTP server. This is what you are running here. You are running, say, some database also, MySQL database. In payroll application, you may say need maybe some other tools. Maybe you need, say, Tomcat, right? You need here an Apache Tomcat server, which is different, right? Than Apache HTTP server. You need, say, here another database, which is Oracle, right? So if you install in the same hardware, this may become overloaded, right? This is a problem. So better to keep it separate, because let's assume these two conflicts with each other, right? So if you install in the same box Oracle and MySQL, some files are overwritten and your entire web server goes down, right? So there could be some conflicts and problems if you kind of put everything on the one server, and it may not take the load, right? So better to keep it in separate machines. But then the problem is that you need to spend money on that, right? But yes, you can't do away with this, so you have to have another server. But now other problem is, even if you have two other servers, payroll you have to run only on 30th or last day of the month, right? 30th or 31st. For rest of the month, it will be idle, right? So what is the solution here? The solution is probably you need separation, right? Solution is maybe you use one server only, use virtualization, right? Maybe, yeah, there is a better solution, because you have purchased two servers, because yeah, assume load issue is there. But what you can do is you may create virtual machines on these servers, right? These virtual machines are not real machines, but they are kind of partitioned within the same machine. So this is another solution. What? And server, or maybe I'll call it VM1, VM2. Right. So maybe. Yes, same you do in all the machines. Right. So
So Tarun, in a physical device, we are storing VM1 data, VM2 data, correct?
yes, you are creating two virtual machines, right? Here in VM1, maybe you put the web service, correct? Web server, right? Whatever we used to have in here, server 1. And in the other one, you store payroll, right? Same here, you will do here. What you will do is maybe only on 31st, you will create this, and maybe you will also create this. On rest of the day, you don't need it. So just maybe switch off this payroll machines, right? Maybe, yeah, if you need very less load, because maybe some processing, some payment you have to process, you never know. Yeah, if some ad hoc payment has to be done, like some bonus, etc., maybe you keep running, but run it in one virtual machine only. But yes, on peak season, you may run it in more and more virtual machines. So this way, you are always utilizing your hardware resources to the best possible manner, right? So you are basically running different environments on the same hardware. You guys have done something like this, I am sure, because in your college, if you have to install Linux on a Windows machine, we create two partitions, right? And in each of the partitions, we install virtual machines. Something similar is there. But in enterprise level, it is more advanced level. So let me now take into detail of how it is done in the operating system level. So if I talk about this simple server, physical server, so this is basically what I will call this is physical machine, right? Or server. And this one I will call virtual machine, right? So virtual machine is a logical concept. Physical machine is a real concept. So yeah, this is what do you have in, say, physical machine. In physical machine, you have hardware, right? So first layer is you need hardware. So which could be
CPU, right? Something.
right. So in, yes, CPU, absolutely. Nowadays, multiple CPUs are also available in a same server. You can have multiple CPUs. You'll have RAM, you will have disk, right? Basically, these are the three important things which you have in the hardware. Assume you are as a dual core 2 duo, or some processors are there in Intel, in AMD. Now multi-processors are also available, right? In servers, definitely there are 2, sometimes there are 4 and 8. Even your mobiles nowadays have octa-core processors, Samsung mobiles, right? 4 and 8 core processors, Qualcomm processors, they come. So you have CPUs, but yeah, not going into exact number. It could be any number, but yes, you have some CPU, you have some RAM. RAM could be in gigabytes. Nowadays, even terabytes of RAM is also possible. Hard disk is also available in terabytes and hundreds of terabytes, tens of terabytes possible also, right? So RAM is also, generally it could be 16 GB or some, yeah, maybe in GBs, basically. In servers, you would have something like 256 GB also, but yes, GBs are there, right? So now this hardware, on top of this hardware, you will install operating system, right? So it will be Windows or so some operating system. OS, I'll write operating system OS. On top of OS, what you have, you'll have, say, for example, if I'm working on Java, I will have runtime, Java runtime, right? JRE. If I'm running C++, maybe I have some libraries, right? Because yeah, for running application, you will need some runtime or libraries. And then you'll have some applications, right? So this is what is there in your physical system. Next thing, let's see. Yeah. So for first server, you'll have this. For second server also, you'll have this, right? So let's say the first one is Java. So we don't have C++ there, right? Here operating system is, say, we have Windows. You know, now see here, this is, assume this is Linux, right? So no need to have Windows here. And application here, you have, say, something like payroll. Right? So you will have, instead of app, I say payroll, right? And here, let's say we have this as a C++ app. So you don't need here Java, right? So these are two servers, right? Again, definitely. Hardware is same. Assume they have exactly the same hardware. So this is possible, right? In the same hardware, we can have multiple applications, multiple operating systems. But one at a time, right? You can't have two operating systems running in the same machine at the same time, right? Sometimes, yeah, some operating systems provide that feature that is called dual boot operating system. But now let me call how it is achieved in virtual machine. So in virtual machine, you have definitely, you will take a bigger server. You will definitely have the same thing like hardware is there, right? So let me copy this part. So we have the hardware.
So Tarun, the hardware will be present somewhere, right? In some location for that virtual machine, correct?
Right, right. Yeah, because really you have to have the hardware, right? So this will be a server. Assume this is the virtual machine server, right?
Yeah.
This is a physical server. This is virtual machine. So how is it different with respect to the setup is what we are covering.
Yeah.
You need another software before operating system. You need another software, which is called hypervisor, right? Now, hypervisor is you can think of it as an operating system which can run multiple operating systems. Or hypervisor is a low-level program or system program which can run various guest operating systems. And in this, you will have multiple operating systems. Right, so maybe more also. But yes, we are interested in two at the moment because in our startup, we have only two applications. But yes, you can run multiple operating systems. So now you will call it guest OS, right? This could be, say, Windows. It could be Linux as well. Right? Anything. It could be there as per your need, right? And definitely when you have operating system, you will have here libraries, and you will also have the application, right? So this is about how a physical server is different than virtual server or virtual machine. Okay, so make it like this.
So Tarun, from lot of days I'm having this confusion between the virtual and physical machine.
Yes.
So yeah, even the interface for the virtual machine, for example, Windows virtual machine, it is similar as like a physical machine, right? We have Google Chrome, everything,
Yes. Yes.
control
Absolutely.
panel, everything.
Right. Right. Right.
So I'm just unable to, how, without physical device, how everything works virtually, that was, my confusion.
Because of hypervisor, you have a spatial application or a spatial operating
Okay.
system or a spatial system software which you have to install before you install operating system, and then you can install multiple operating systems on top of it, and in this way you may run multiple servers in the hypervisor.
Yeah. And what about this hardware, RAM, GB? It should be physical or, can it be available virtually?
Yes. See, let's say this is 16 GB, right? So what you can do is you can run two servers, two virtual machines on this and allocate 8 GB, 8 GB, right, to each of these. So what you can also do, you can sandbox the environment and even allocate dedicated CPUs and some memory in the physical hardware to be utilized by the virtual machine.
Yes, yes, that's my
Correct?
point.
So
Yeah.
yes, if you have 16 GB server, you can allocate 8 GB to one machine and 8 GB to other one, right? You just can't do 16 GB in two because that's not possible because you have only total 16 GB only. So this is not possible. For this, you need 32 GB. But yes, out of your actual physical hardware, you may allocate this as you may create two servers of some different configuration, hardware configuration and capabilities.
So when we having virtual machines in the physical server, we cannot install other software, right?
Actually,
No.
there are dedicated and pooled VDI will be there, right? Some virtual machines.
Yes,
In dedicated, we can install everything.
right. Absolutely.
In
Absolutely.
other way, if we install software in physical server, in the virtual machine, can we use it? No, right?
Yes, yes. See, yeah. So now your question will be, why not always use virtual machines, right? Why
Yeah.
to use physical machines, right?
Yeah.
You'll always get more flexibility. But yes, you should also understand some performance overhead will be there in virtual machine because hypervisor is some additional software which is running, right? So slightly degraded performance you will get in hypervisor, right? Because it's a virtual machine, is a virtual environment. So it will be slower than the real hardware. But yes, you get more flexibility, right? So this is one disadvantage of virtual machine. You may get slightly degraded performance because you have one more application, one more software which is running on this machine, hypervisor. So real examples of this hypervisor or virtualization environments are, there is one from VMware. Right? So VMware is a company which has mastered or which is the pioneer in virtual machines. Also, there are various open source implementation. One from Oracle is known as VirtualBox. So you can install it in your machine also, these VirtualBox. And within VirtualBox, you can create another virtual machine and install Linux or any other operating system. Even you can install Windows also. But yes, no, Windows within Windows may not make sense. But yes, if you may install multiple images of different operating systems and run it one at a time or run it simultaneously as well. But yes, you have to understand that there is a limitation of physical hardware. It will be running on the physical hardware only. Right. So now let me also brief about containers. So problem with this is, yeah, you are running here both these things, right? Now what you have done is you've combined these two in one virtual machine, right? This is here, this is here, right? No problem. But yeah, still you have problem because more operating systems will you run, you will get into performance issues. You have to say, assume if you have to restart Windows, it takes time because you have full operating system here in virtual machine. Virtual machine has full operating system. Nothing is shared between these two environments, right? So this virtual machine 1 and virtual machine 2 are completely isolated. Nothing is shared and you have to do the entire operating system maintenance. In this, you have to have thorough documentation of what to install, how to install. Every step you have to follow manually and you have to follow as if you are following in a real hardware. Right? But let me talk about containerization. We'll discuss in detail in the next class, but I'll just introduce. So assume what I do is, here the problem, biggest problem is this part, right? And you can switch between different virtual machine, but still it takes minutes to switch, right? So if you have to switch the switching between virtual machines takes minutes. Basically, you may have multiple virtual machines. No, even say you can have, say, guest OS as Unix. You have just installed it in case you need it in future, right? But yes, this you have kept as a stop. But whenever you need, you can start this and you can stop others, right? So virtual machines, you can start and stop as real hardware. But switching, when you are switching or starting, stopping, it takes time. Because even if you have to shut down your PC, it takes 1 minute, right? Slowly you will see some icon animation and then it will close. And once it stops, then only you can start the second other operating system. So that's why I've written here that starting and switching between takes minutes, right? This is the drawback here. But now in high scale application, you should get the flexibility to switch in seconds, in milliseconds. Because sometimes the load increases, traffic increases in few seconds. So here, yeah, you will always have in containers. So now I'm covering containerization. Containerization is a special kind of virtualization, right? In containerization, yeah, this is common because hardware you need to have a physical server. So basically you will also have network connection, right? So in addition to RAM, CPU, disk, you'll have network connection, the network connectivity also everywhere. Let me write this also here. Right, so when then, right, so and same thing you will have here also. Right? Right. Now you don't have hypervisor in containers. You will have the operating system, which could be anything, whichever you have. Right. So the next layer is operating system. On top of operating system, you will install container engine. This is called container engine. This is Docker, right? Most common one nowadays, Docker is the leader in containers. These containers are like, so container engine is the common kernel. So basically what they have done is they have created a kernel, Linux kernel. Even there is Windows kernel based container engine also available. So you can think of, there is a kernel, there is a common kernel, right? And on this common kernel, you can run various libraries. Basically runtimes, right? So maybe I will run in one Python. I'll run other one, say Java, JRE, and write like this. In other, I'll run C, C++, right? And then on top of it, definitely I can run apps, right? So one. So I can have several apps running on it. So the advantage here is, since the kernel is shared, you can switch between one container to other very fast, right? So container here in this case is this part, right? So yeah, you will have apps everywhere. So I have not drawn here, but we'll have here, and you have at other places also same structure. right? So just for speed, not drawing it again, but yes, we'll have app here as well. And yes, dot. Let me draw dot. So yeah, this is how it is. So since the kernel and operating system are stable, what you change is the runtime and the app, right? You can switch between different apps in milliseconds. Now, what is container engine? Container engine contains, as I said, common kernel. I can say shared kernel, right? Better I should write here, shared kernel, because the kernel will be there in the host operating system. And then you have network interface, optimized file system, right? So all these components will be there in container engine or in the container. And yeah, in each of the container, you will have the shared kernel, you'll have network interface and optimized hardware. And here we will not have overhead, significant overhead. Yeah, tell me.
Like remote desktop connection, there is it, right?
No, remote desktop connection is different technology. It's not a virtual machine, it's a screen sharing. So what actually remote desktop means is you are just, it's like capturing screenshots and capturing the mouse movements, right? Transferring these mouse movements. So you may get multiple people connecting to remote desktops. So that's a different technology. Yeah.
Yeah, got it.
Virtual machine. Yeah, it's not virtual machine. It's screen sharing, right? I'm sharing a screen. You are seeing it. I can give you control, right? In video conferencing, you have that feature, right? I think this remote control, then you will be able to control my desktop also. So this is lightweight containers. Basically, the containers are lightweight virtual machines. Yeah. And you can start and stop it few seconds, few milliseconds, seconds at max. And in this case, right, the problem is I have hosted real applications. And when you are running any business critical application, what happens? There will be some security threats coming almost every month or every week, every alternate week. There will be some virus. So you have to put some patch, right? You have to keep, when you have to put some patch, that means you have to upgrade the operating system. When you have to upgrade the operating system, that means you have to restart. And upgrade process will also take time. And if you are running multiple operating systems, you have to do it multiple times. So there's a lot of overhead here. In case of containers, since this is shared operating system, you don't have to take care of doing this in the container. You have to do it only in the entire machine. So this is difference between containers, and I will call containers are lightweight virtual machines. There's nothing, it's same concept as lightweight virtual machine. I would say suggest go and play around with Docker. Right. So this is the software which is Docker software. You can sign up, download for your operating system. It is available in Linux, Windows, Apple. You can then run any application as a Docker container. I highly recommend that you should make yourself comfortable with using Docker. You don't need to install any application on your operating system. You can always install applications on Docker, right? But yes, as with any operating system, not all applications are available on Linux, or not all applications are available on Windows. There are also only few applications which are available in Docker, right? So, but yes, most of the application for developers are available in Docker, because Docker is a platform popular for developers, right? So you will get many applications, many development tools on Docker. So this is what I wanted to cover for today. We've given you introduction about Docker and about virtual machine and physical hardware. So we'll cover more details and also about some basic understanding of Kubernetes in next session. And then we'll do one high-level design of Hotstar application. Hotstar or YouTube or Netflix, all will have similar architecture. Zoom call, right? There are slight differences only in Hotstar or with YouTube and with Zoom. I'll cover that in the next session, along with some more topics on containerization, and we'll cover Kubernetes also. Great. See you then. Have a nice evening. Have a nice Sunday. See you.
Thanks, sir.
Perfect. Perfect. No further question. We can close this session.